Hey everyone, this is 4.3 Triangle Congruence, but this time it's by angle, side, angle, and angle, angle, side. All right. To do now, they want you to mark the triangles appropriately based on the given congruency. Well, the first one, they want you to show side, side, side congruency. So we could say AB is congruent to DE, BC is congruent to EF, and AC is congruent to DF. With side, angle, side, now, there's a numerous amount of ways that we can do this, but I'll just say that FG is congruent to JK, angle F is congruent to angle J, and then side FH is congruent to JL. Now, you don't have to use those three. There's many different ways that you could do this, but that's just one given example. Okay, so we have the angle side angle postulate today, or ASA. If two angles in the included side of one triangle are congruent to two angles in the included side of another triangle, then the two triangles must be congruent. Okay, so notice the included portion this time is the angle because it's in between, the side because it's in between your two angles. So, using angle, side, angle, it says which two triangles are congruent by angle, side, angle, and to explain. So let's just answer these questions to help us explain. What do we know about the given images? We know that angle U is congruent to angle E is congruent to angle T. Okay, so that's the first thing we know. The second thing we know is that angle V is congruent to angle O is congruent to angle W. And last, we know that side UV is congruent to OE is congruent to WA. Okay, it says which sides are included in between the given angles. Well, this time there's only two sides that are included, and the included sides are UV and OE. Side WA is not in between the two angles. Okay, WA is kind of off to the side here. So it says which triangles are congruent by ASA? Well, that would have to be triangle SUV is congruent to triangle NEO. Okay, of course, we're going to have to do proofs on these too. It says members of a teen organization are building a miniature golf course at your town's youth center. The design plan calls for the first hole to have two congruent triangular bumpers. Prove that the bumpers on the first hole shown at the right meet the conditions of the plan. Well, if you can't see it, here's your triangles. 1 and 2. Okay, so there's our two triangles, and they do show some congruency markings in there. Okay, and the first thing that they tell us is that AB is congruent to DE, which they show with the tick marks. Okay, so let's write that first. AB is congruent to DE, and that's a given. Okay, and then they tell you angle A is congruent to angle D. Also a given. Okay. Then the last given statement says angle B and angle E are right angles. And that's your given statement. Now, just because they're right angles, we didn't say or use the congruency symbol yet. So I need to come up with some sort of reason as to why these angles are congruent. So what you're going to write is angle B and angle angle B is congruent to angle E. And your reason is that since both of them are right angles, meaning they're 90 degrees, all right angles are congruent. Okay, so now we have an angle, a side, and another angle. A, S, A, S, A. So we can say that triangle ABC is congruent to triangle DEF, and that's because angle side angle is congruent to angle side angle. All right, number 3, same process, okay? Just with a more generic picture. So start with your givens. Angle CAB is congruent to angle DAE, and that's your given. Okay, so angle CAB is here, DAE is here, and those are your vertical angles. Then we have side BA is congruent to EA, also a given. So here's BA and EA. So we have an angle and a side, an angle and a side. We need that last angle. Again, we have that statement about right angles. Angle B and angle E are right angles. So we can say angle B is congruent to angle E because all right angles are congruent. So now we have angle, side angle, and we could state that the triangles are congruent. Triangle ABC is congruent to triangle AED because of angle, side angle being congruent to angle, side angle. All right, the other one we're going to learn today is angle, angle, side. So if two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side of another triangle, then the triangles are congruent. Now, biggest part here is corresponding and non-included. Okay, meaning it does not fall in between the two angles. Okay, the side is on another side, non-included. All right, so here would be your first example. Angle M is congruent to angle K, which is a given. And here they are, angle M, angle K. Then we have side WM is parallel to RK, and that's a given. So WM and RK are parallel, and what I'm going to do is I'm just going to extend these lines a little bit as if they keep going. Okay. So we need two angles and a side. Now to go with this parallel statement, you realize that this is a transversal that cuts through two parallel lines. Okay, so what we can say is that this angle right here, which is MWR, angle MWR, is congruent to angle WRK, or KRW. And that's because we have parallel lines cut by a transversal, and these are alternate interior angles. So we can say alternate interior angles are congruent. Okay, so we have our alternate interiors. And let me just clear this up a little. Here's our alternate interiors. We have angle M being congruent to angle K, so we have angle, angle, And now we just need a side. Well, these two triangles share a side, which is WR. WR is congruent to WR, and that's because of the reflexive property. So finally, we can say that triangle WMR is congruent to triangle RKW because angle side is congruent to angle side. All right, more angle side practice. It says given angle S is congruent to angle Q. So S congruent to Q. There's your first angle. We have RP bisects. That means to cut in half angle SRQ, which is this giant angle right here. But if we cut those angles in half, that means that angle SRP is congruent to angle PRQ, because if we cut a big angle into two equal angles, the two tiny ones are going to be congruent. So we can say that SRP is congruent to angle QRP. I'm sorry, we have a given here. And this is because we can write definition of an angle bisector. And now all we need is a side. We know they share side PR, so PR is congruent to PR because of the reflexive property. And now we have an angle, and a side. So the triangles are congruent. Triangle SRP is congruent to triangle QRP because of angle side being congruent to angle side. All right, your last one says determine whether the triangles are congruent. It says use the diagrams at the right. Which of the following statements best represents the answer and justification to the question, is triangle BIF congruent to triangle UTO? Okay. Well, if we go back to our definition here, we know it can't be choice. We know it can't be choice A, because this goes angle, side, angle, side. So we know it can't be angle, side, angle. But the only problem is if we look at these, I have a 1 with a 1. I have angle I congruent to angle T. And then we have the sides, which is BF congruent to OS. But if you look at the placement of those sides, they're not in the correct or the same spot. So we can actually say that these are not congruent because FB and OT are not corresponding sides. And that was something I pointed out here. The sides for angle, side need to be corresponding, meaning in the same place. Okay, so really, you wouldn't be able to have this here. It would need to be over here on this side. Okay? So your choice or your multiple choice answer is B. Exit slip. You guys try this one on your own. I'll check it when you submit. Which postulate or theorem could you use to prove triangle ABC is congruent to triangle DEF? So you have two examples, so I'm going to need two answers. And you're either going to have an answer of angle, side, angle, or angle, side. All right, thanks for watching. Don't forget to